I've been working with Kubernetes for quite a while. Before I was at Google, I was at Red Hat and as their OpenShift, which is their Kubernetes distro. I was the specialist on that side. So been working with Kubernetes for a long time. So the way I'm going to walk through this presentation is to give you a bit of a journey, where we started, where we're kind of at, and hopefully where we're going. So with that, I kind of start in with the classic monolith or microservices, because this kind of prompted containers to become a reality, right? Monoliths, were like the castle on the left. I always like the castle. It's robust. It's secure. It's all the things you thought an application should be, but it's not very modern, right? You can't move it. It's got no agility. When gunpowder came along, it was kind of obsolete for its protection. So you need the idea of microservices, which is really the container foothold, to be more agile, have a lot of different disparate services that do different things. So I use that as an analogy to kind of set the table on why containers kind of came relevant, and then that led to really Docker, right? And Docker did a great job of kind of taking this concept that was Linux-based of containers and building on it. And quite frankly, you could do these quick commands, small Docker file, apps up and running. It's great. The problem with Docker is once you actually tried to go production with it and do scale, it was a mess, right? You couldn't do things like high availability, how do you do persistent data, how do you do networking across multiple services, etc. So all of that really led to container management. Like how do you manage it? Docker had their own idea at first. Actually, they started with Docker Swarm, if anyone remembers that, and then they went to Docker Data Center. Mesosphere, I mentioned OpenShift. OpenShift did not have a Kubernetes as its core engine until version 2. Version 1 was like Gears and Cylinder, these other names. It wasn't anything to do with Kubernetes. So all these different players, we were trying to figure out how do we have an orchestrator, and as was mentioned, Google presented Kubernetes based off of their internal Borg. So Borg is what Google still runs as their main container orchestration for legacy apps, and they built Kubernetes based off those principles, and that led us to basically Kubernetes eventually winning out in a very small time frame over all those other ones I'd mentioned on the previous screen. So Kubernetes now is the default container orchestrator, and it does all the things that just Docker itself can't do without an orchestrator, right? So 100% open source, etc. One thing to note here is abstractions are argumentative in the IT business. People love them, people hate them, but ultimately they're a part of our fabric, right? So the operating system abstracts things like the kernel and other things. Kubernetes now comes as another abstraction on top of that allows you not to really even care that much about the operating system, which is key to basically the whole app modernization. I have less time to work on the operating system and more time to work on my app. And really at the bottom line there, manage applications is the core, the reason that Kubernetes, we talk about it and why it's relevant, but at the same time, we don't want to know anything about Kubernetes long term. It's just an abstraction layer, it enables us. So really, where to start in the app modernization? I like to use this because there's many different reasons you're getting into this business. Some are maybe your public website. You just want a good user experience in the top left, low latency connectivity, so that you have this ability to wherever my application runs, it's closer, right? So that's kind of also a regionality thing. Meets to the high availability too. If I have a region go down in the cloud or even on-prem, I want to be able to throw it up, etc. Monoliths weren't very good at this, and a lot of them weren't built on the vertical scaling principle. Containers and Kubernetes really helped us. So I won't go through all of this, but these are all use cases. You, as the customer, have to figure out why you're doing containers, what's the value for you, which use cases you fit into, and then kind of go from there. Okay. Then it's important to talk about who builds it. So you're probably hearing more and more about the platform team, right? DevOps, the nebula of DevOps is kind of going away, and you're hearing more of this platform team, which is essentially just another way to say DevOps, right? You have the developers on the left and really operations on the right, and where do they meet, where do they overlap? Really depends on your opinion on your company and who you want to do what. Ultimately, I think what's important to understand here, development best practices are taking over operations to where no ops is kind of the old end game, right? We want to basically bake it into the developer process to where operations is part of it, but not something that we have to have teams run. And so easier said than done, but platform teams, how you divide up your company is important. So now you know who's doing it. Where do you start for your app modernization journey? I'm using on-prem. It doesn't have to be on-prem, but typically that's where it starts. A lot of people have VMware, right? So you have your VMs. What type of resources are you running? Right? What are these VMs hosting? One app for one VM? Do you have it multi-tenant, etc.? You need to know what your actual footprint is first. Easy enough to do. You kind of take a view of what your VMs are, take a look at that. But then you have to go one layer deeper, and you have to look at the applications on each one of those VMs. And really, there's tools out there. Google has a number of them. All it's doing is assessing an application on a rudimentary level to figure out, is this application worthy of containerizing? Is it built to do it? You need to know the frameworks. You also need to know things like integrations. So for instance, this is a quick screenshot of each one of these apps. This one falls into the good fit. You can see the top, it's got the little check mark, good fit, because a lot of the dependencies are fine for containerization. If you have something like that mount point that says, you know, kind of an exclamation point, maybe you have an mount point that may need to be modified in order for containerization. All of this is important to just understand the nature of your app. Obviously, you have different frameworks that contribute. Things like .NET Core now enable you to containerize very easily, but if you're on .NET Framework, more difficult. Right? So you have to understand which applications fit where. Assessments like this are key point. I want to pause here for a moment and say that you don't want to spend all of your time here. I've been doing this a long time. A lot of companies get wrapped around the axles on this stage. All they do is keep assessing their applications. The historical, if it's over a certain size, it can't be containerized, is not true. You can containerize multiple gigabyte applications. You can just take a monolith and essentially put a wrapper around it if it has a fit. You can do those things. You just need to do your 80-20 rule, which 80% of your effort should go to covering up that, right? Leave the 20% if they don't fit, move on. So don't over-evaluate here, but you need to know what your landscape is. Then you have to talk about migration. I'm using an example here of migrating containers from on-prem. You're going to containerize and move them to a cloud, right? I'll use Google, I'll also show AWS. So you take a legacy app, hasn't been containerized, you look at it, maybe it's a good fit, and we have tools that basically allow you to do Kubernetization. Very easy for me to say, right? Kind of a funny term, but all it's doing is taking an application and it's breaking it down into what would the Docker file look like to containerize this? What's the app config, right? So like a manifest file on Kubernetes, what would that look like as a deployment? It breaks it down. Google, we have tools once again for that. Anthos Migrate is what this is using. So it basically looks at an app and you can run it against it and it'll give you an app config file, it'll give you a Docker file, and it'll give you the images that would make that up, right? So maybe the core OS at the base, your application, any adjustments, etc. So that is very valuable. If you're under the opinion, and I am, but that Kubernetes is really here to stay and it's an abstraction layer for all containers, having this breakup is really important because now you have your applications in this kind of declarative form, right? They're sitting up in repos. So I have an image registry, I have an app repo and a config repo. They've been compartmentalized and I can now deploy them to any Kubernetes distro. And I think that's the nature of what we want to get to from any enterprise company, is getting your bits down into this repeatable process, right? So if we're going to deploy, we have that config repo. This is where we might modify for where is the ultimate destination. You have to define, am I going to go one zone? Am I going to go 2 zones? Do I have that network blast zone, right? Do I want to keep it in a single subnet? Do I have multiple subnets, etc.? GKE is Google's distro of Kubernetes, right? Google Kubernetes engine. So we're going to say we're going to move this legacy app. We're going to push it in there, right? And we're going to basically modify those repos, that declarative notion of saying, I want to run it, in this example, in a single zone, in a single region. If I decide I want to make it more highly available, I modify simply the config repo and I push it out to a second Kubernetes distro. So this is the way we get velocity, right? We start to get our apps removed from the baseline infrastructure. Yes, it is running on Kubernetes, but if you're using, as Google does, Kubernetes in its really rare normal form, open source form, what you can do is basically bring on a second provider, right, like AWS, and you could take that same notion, modify the config repo, and be able to push it to Kubernetes in a different location. This is key, right? This is how we can basically start to use Kubernetes and be agnostic of our landing footprint. It does come with complications. Kubernetes has been historically very poor at federation, right? Running multiple clusters that can actually talk to each other. A lot of the providers, Google is one that brings along a way to add federation to clusters, and those can cross, in Google's version, Anthos, can cross providers. As long as it's an acceptable Kubernetes distro, you can take EKS, which is Amazon's managed Kubernetes service, right? Elastic Kubernetes service. You can just essentially add an agent onto the nodes that run on Kubernetes. And what you can do is extend your configuration management to look the same. And what I mean by configuration management, things like namespaces, right? We want to have normal namespaces on cluster up at GKE, and we want to have that same namespace defined down at EKS. This is done by a Git-based configuration management called Anthos Configuration Management. You essentially declare it in your config repo. The cluster's phone home, they find out their configuration, and they normalize. Now, you can have different ones in different clusters. That's very acceptable. But you do want it to be opinionated and declarative. So I define these things from a service, from a config repo above. The next thing I also want to do with my applications to tie them together is I want to use a service mesh. So service mesh, Google uses Istio as the main control plane, and Envoy is the proxies. Right? So the proxies, those not familiar with Envoy and Istio, it's essentially just a sidecar notion. So Envoy is a sidecar proxy. C++, I believe, is the nature it's written in. It sits alongside your applications as a sidecar, just like the old-fashioned World War II, right, motorcycle with the little sidecar. It sits alongside, so all traffic goes in or out of your application goes through that sidecar. Envoy liaisons with Istio. We all see all the applications, all the services, service discovery, how do we want to secure it, etc. They're tied together. Good way to keep your clusters talking to each other using open source. Okay? So another thing that keeps important for app modernization. Now, I highlight on the right-hand side this legacy app 3 came back with a no-fit, so it's really not going to be containerized, or it's too difficult. I don't want to spend the time to containerize it. So you want to kind of have that fall into a similar form. It's not going to have a manifest file in the config repo, but it is going to be something you want to basically put an app repo together. Your config repo here might be the legacy, call it golden VM, right? A VM image, a baked image that is your config, right? So it's not a manifest file for Kubernetes. It's more of a legacy VM instance that you define for your app. But it's declarative. Once again, it has to go in this type of VM, and it starts up, etc. And you can also use that same logic then to move it, right? If you have a failover, you're a multi-cloud provider, you have that same notion. Now, the instances on AWS and the instances on Google have different names, but you can mature those, have them sitting up as a snapshot, and start those up at any time. So another way to essentially move everything into compartments and modular and deploy across clouds. Okay? So next thing is, how do you automate? And another key part for app modernization, start with the old app monolithic. believe it or not, it still had some type of CI/CD range. It might not have been automated at all, but you did have to build it, right? You did have to push it somewhere, and then you did have to deploy it, right? So that was the nature of Monolith. Microservices come along, they really add that same notion, but you start building the steps to be automated. So if someone going into a console and logging in and doing this, you want to put it into code, right? Infrastructure is code for the actual assets and application code for the builds. When you blow that out a little bit more, they typically follow these 4 type of steps. Build and archive the artifacts, right? You want to build the configs, meaning the deployment where they go. You want to commit them to a centralized repo, so you keep everything versioned in a single spot. And then you want to have configuration management oversee it, right? So you keep everything from a security point. So on the bottom, talk about that notion of platform, right? So the platform admins do a lot of the things like IAC, the configuration location, and the developers do the code. Where those teams blend or who does what is up to you once again, but this is the notion of what it should kind of look like, best practices. It goes through, maybe you have things like Jenkins still as a CI tool. That's great. You know, you can use Jenkins, you can use other tools as well, but you need a CI tool, build these things, push them up into the repos, and then ultimately you want to move them along the pipeline, push them out to centralized locations, that declarative notion. Okay. So another way to kind of just depict how you should automate this from a best practices. Most people kind of know this notion, but I like pictures. It's good to put them in place. Like CI is different than CD. Which tools I use, how to do that. Okay. The next thing is, you know, talk about app modernization, but I think we also have to look at machine learning, since there are applications, but they've had their own lifecycle management. How do we incorporate those? First, you just have to identify that the tasks are somewhat different. Right? There's training going on, there's experimentation, there's other things that happen. But that's not to say that they're not falling into the same CI/CD like pipeline notions. You should still have things that use the tools that you have to do that. So essentially, you take these tasks and you build an ML pipeline around that. So you're hearing this term more and more now, ML ops. And ML ops is essentially just CI/CD, right? But it's for machine learning. It does some slightly different things: data validation, transformation, evaluation. The heart of a modern ML ops should be based in, once again, a containered world, right? You want each of these bits to be containerized. In ML ops, you want to have things like a metadata store. That's where you're just keeping pieces of each run that you do. So I think that's another best practices that CI/CDs have to evolve to. They have to start capturing their versioning in a centralized location. This is also really important for big data. We tend not to have big data fall into the same ML ops or CI/CD pipelines, but they should, right? You should start basically using the core concepts for all the assets in IT. Ultimately, for machine learning, you just want to push those out to a location here at the end, iOS on the right, Android, etc. Right? You're essentially having a location. You're serving out these models so that they can be used. Maybe you're running batches against them, whatever. Once again, you need to keep track of which models got pushed where. Under the covers, like I said, is truly a modern ML ops is using Kubernetes. So you just tie these together with a declarative pipeline and say, here's my pipeline that I define for all these assets. So this, I've thrown a lot out there, a lot of different things, but they're pretty much the blocking and tackling for using Kubernetes and containers to modernize your apps and push them into a CI/CD type of notion. Also a similar format for data, right? Like I said, data has been historically kept out of this realm. It's typically not looked upon as a CI/CD process. Terms like data mesh, data fabric are becoming the norm now. Those essentially are taking these notions and productizing data. So data would have a metadata version of it. Maybe you have a data store to say this is my data X, and I'm going to call it version 2. and I'm going to expose that to all the other departments within my company. Legacy big data just had, call it ETL jobs, and the notion of this big data lake where we just have a dumping ground where everything goes in there, and then it's up to the overworked data scientists and data people to pull apart that, find value, and then give it back to the business. I think that'll be flipped on its head with data mesh. You're going to essentially now have it productized, so where data is like an API exposed, and external clients simply call that data for the information they need, and they can assemble it however they need. So I think that's going to be what you see for a big data company. And with that, that's pretty much the end of the presentation that I had.